Good morning, my dear students. Coming to the next topic, that is after studying the FEM and FEA and what you mean by continuum method and what do you mean by numerical method, analytical method. Let me understand in this class what is the difference between FEM and FEA. That is first one. The second one is the difference between FEM and FDM. Okay, that is a continuum method versus FEM, and what is the difference between analytical method, numerical method, and experimental method. Okay, we will study this. Okay, so here after studying all those theory things, okay, let me understand today class only the difference between the four differences. Okay, that is the four different types of methods. Okay, so first one is what finite difference method and finite element method. Okay, so this is most important question that frequently they are asking in the examination. Okay, write the differentiate between FDM and FEM. Okay, here look at the FDM. Okay, finite difference method, it is shortly called as FDM, and finite element method, it is shortly called as finite element method. Okay, both are numerical method only, but this is something we cannot solve some numerical problems under this finite difference method, but we are going to use this finite element same problem we are going to solve in this finite element method. Okay, so first difference is what it is what is the title is what the finite difference method and finite element method. Okay, so both are the numerical method only. Okay, second one is what it can be applied only the static problem. Okay, so this FDM tool we are going to apply only the static problem. Okay, static problem nothing but what here in the given problem or a given element. Okay, so after dividing the given element we are going to where the displacement is not linear with the element. Okay, such type of problem we are going to call a static problem in the FEM. Okay, whereas here we are going to solve both the problem, that is as well as static and dynamic problems. Okay, the third one is in this we are going to use the differentiation only. Okay, so to solve the FDM problem under FDM problem we are going to use only the differentiation, but here we are going to use the integration as well as differentiations also. Okay, so it is a weak form of the FEM. Weak form of FEM nothing but what some problems you cannot possible to solve by FDM method, hence we are going to call as what weak problem. So here any type of problem that is even more than two loading or different material composed of that body we are going to solve by using this finite element method. Okay, that is the meaning of weak and strong. Okay, the same this is a weak problem. Okay, so we cannot apply some weak problem, we cannot solve by using this FEM method. Okay, so come to this finite element method, it can be applied or it can be solved by the complex problem. Complex problem nothing but what the complicated, that is a very highly complicated problems we can go into solve by finite element method. Okay, so coming to the sixth difference, nodes are at the center. Look at this is the element, so here the nodes are present at the center. Okay, here center, but whereas here the nodes are at the each element, that is each corner of the element we are going to present, so that we are going to get better result as compared to this. Okay, so nodes are here located at the corner of the each joint or discontinuity element. Okay, coming to the seventh one, it gives the value at any node. Okay, so here it gives the value at node only. Okay, so here look at here in this problem you are going to get the node at the center only. Okay, so here we are going to get the solution at node only, but it gives the value at any point. Okay, each point we are going to identify the stress strain at. Okay, so because the nodes are present at each corner. Okay, so now next eighth one is curvature cannot be easily modeled. Okay, the problem consists of little bit complicated curvature, means we cannot solve by FDM method. Okay, then this by using this one, by using same problem we are going to solve by finite element method. Okay, even curvature like anything. Okay, but we are going to solve by easily with the help of this finite element method. Okay, come to it need large number of nodes to get a good result. Okay, but since the nodes are present at the middle, so we are going to not get the accurate result, but here we are going to get it is a good result. Okay, as compared to get the favor to get the good result. Okay, and it makes the pointwise approximation and it makes the piecewise approximation. Okay, so these are the some 10 difference between the finite these are the 10 difference between the finite difference method and finite element method. Okay, so you have to most important question. Okay, now you have to remember this. Okay, both are numerical technique only, but FDM cannot be used widely used, but FEM is present day we are going to use almost all the sector. Okay, come to the second difference. Okay, this is also most important. Okay, so what is the difference between continuum method and finite element method? Okay, so first is complicated problems are very difficult to solve by using continuum method, and complicated problems are solved by using this FEM tool. Okay, second difference is solution given by the entire body. Here we are going to get the solution at entire body, we are not getting the solution at each body. Okay, so this is also one of the disadvantage for using this continuum method. Okay, solutions are given by the each element, that is step by step you are going to get the solution. Okay, solution nothing but what stress strain displacement, that one. Okay, so it is a analytical method, it is a numerical method. Okay, So continuum method is a nothing but is an analytical method. Okay, so it cannot handle non-linear problem, but it can handle the FEM method is what it can be handled a non-linear problem also. Okay, that is displacement is not vary with the element. Such type of problem also we can solve by FEM method. That is called as non-linear problem. Okay, structure is made up of more than one material, then it is difficult to solve by using continuum method, whereas such type of problem you are going to solve by using FEM tool. Okay, these are the most important 5 difference between continuum method and finite element method. Okay, so coming to the next difference, that is finite element method and finite element analysis. Okay, it is shortly called as FEM and it is shortly called as FEA. So FEM nothing but what it is a numerical method, analysis nothing but it is a simulation method. Okay, that is the difference. Okay, so finite element method it is called as finite element analysis. Okay, what is the definition of finite element method? So it is a numerical method for solving the problems of engineering and mathematical physics for complex geometry, boundary condition, loading is called as FEM. That is it is a numerical method for solving a complex problem. Those problems consist of what? Subjected to a boundary condition, bound, loading, geometry, etc. Okay, such type of problem you are going to call as finite element method. So what is mean by finite element analysis? Okay, it is a way to simulate the loading condition on a design and determine the design response to those conditions is called as finite element analysis with the help of software. That is we are going to use in the ANSYS software. Okay, so what all are you are going to study in the theory, that is calculation by manually, the same you have to execute in the software, that is simulation. Okay, it is a way to simulate the loading condition. Okay, that is called as finite element analysis. Okay, this is a numerical method, this is the analysis method, simulation method. Okay, so that is the difference between these. Okay, this is also very important. So both are same only. Finite element method, this is finite element analysis. Analysis nothing but what? By using some software we are going to simulate the given problem. That is analysis, how you are going to distribute the stresses, strain, the displacement variation over the given bar or given plate. Okay, so coming to the next one, so what are the difference between analytical method, numerical method and experimental method? Okay, so here I differentiate here. Analytical method is a classical approach. Okay, that is 100% accurate by doing this closed form of solution which will give and complete in itself. Okay, so whereas numerical method it is a mathematical relation, that is it is a mathematical representation and it is a approximation, assumption should be there. Okay, that is boundary condition we have to assume and result must be verified experimentally. Okay, so result after getting the result from the numerical method we have to verify it with an ANSYS software or any software. Okay, so experimental method means what? Correct procedure. Okay, we have to follow the correct procedure. Okay, and times consuming and expensive, physical prototype required for 3 to 5 times required. Okay, so again continuation method. What is the analytical method means? It provides the closed form of a solution. Okay, and example for is theory of bending. Okay, so what are the example for numerical method means? These are some of the courses, that is the example for numerical method. Okay, FEA, finite analysis method. Okay, finite element method, finite difference method, of finite volume method and boundary element method. Okay, these are the syllabus, these are the tools which are using numerical method, but we are going to study only the finite element method. Okay, among these this is the best, that is FEM tool. Okay, experimental method means same, for the example what you are going to conduct in the lab. Okay, that is what experimental method. Okay, so again I shown here what you mean by analytical method and numerical method and experimental method. Okay, so analytical method is nothing but what? It is involve the solving of entire system on a one operation. Okay, so this is what the analytical method. Okay, and it involve the defining the equation for each element and combining operand the given solution. Okay, whereas numerical method means what? The finite it is widely used method for numerically solving. Okay, that is a differential equation arising engineering and mathematical modeling problem. Okay, experimental nothing but it is a correct procedure. Okay, we have to follow the correct procedure. Okay, and the second is in this method a general equation can be derived. Okay, values could be determined at the required point only, but it is here in this it required very few restrictive assumption to solve the numerical problems. Okay, so experimental method means what? In this type of the prototype it is made. So here normally the prototype is made and testing is carried out on the prototype. Okay, so next one is the calculation is carried out manually here. Okay, but here it can be treat complex geometry, support and loading condition. Okay, and in this method, so this support is costly both in terms of model and instrumentation, test facility and actual test also. Okay, so the next fourth difference is this is a method is advisable only when the body is in regular shape. Okay, loading boundary conditions well defined. Okay, in the given problem the given quality, the given data is given means we are going to use this analytical method, whereas these are the most cost effective than experimental technique. Okay, even without giving any data also we are going to solve according to the by assuming some assumptions. Okay, so here experimental method means for each loading condition separate prototype and fixture to be made. That is what the experimental method. Okay, what are the methods of this analytical method means what? How you are going to classify this means here exact method. Okay, in this separation variable method will be there, and approximation method, that is Rayleigh-Ridge method and Gallagher method. Okay, these two topics we are going to solve the numerical problems. Okay, that is what in module 1 we are going to solve these two method problem. Okay, Then what are the numerical method problems? Okay, these are some of the numerical method: finite element method, finite difference method, boundary element method, numerical integration method. These are some of the tool that is numerical methods are going to solve FEM method. Again, these types means this is any one testing machine. Okay, types are what? Brittle coating material, photoelastic specimen or technique. Okay, these are some of the difference between the analytical method, numerical method, and experimental method. Okay. So here you have to remember the first three definitions. This is not asked in the many times in examination, but first three definitions they may ask in the university examination. What is the difference between finite element method and finite difference method? Okay, this is most important question. That is starting three. That is FDM versus FEM, and this continuum method versus FEM, and FEM versus FEA. Okay, so you have to remember these definitions. Okay, so I hope you understand this today this video. Okay, what is the difference between FEM versus FEA, and FEM versus FDM, and continuum method versus FEM, and the differential analytical method, numerical method, and experimental method. Okay, so I hope you understand this. Thank you. Okay.